Hi, I'm Henry Gilliland, a mechatronic specialist with Electric Supply and Equipment. This is Jonathan Durand.
Hey.
Nice to meet you, Jonathan.
Good to meet you.
Can you tell us a little bit about this machine, what it's doing, what it represents, I guess?
Sure, absolutely, yeah. So at Eagle Technologies, we've worked on several projects here that make battery modules, and so this is kind of mimicking some of the components that we would have on one of those machines. So right here, we've got a Comau robot. It's actually a unified robot.
What does that mean?
So that means it's actually controlled by the PLC, and it has two servo drives that are controlling the robot itself, instead of having your typical robot controller.
What type of servo drives are you using?
Cognex 5700s.
Okay, so no separate robot controller like you usually have with a traditional robot solution.
That's right.
All Rockwell.
Yes, and that way there's actually only one programming language, which is really nice for a controls guy like me. And so what's happening is it's taking the 4 battery cells and it's bringing it over here to the eye track. It's placing 32 cells in here so they can come around and get scanned by the Cognex vision camera. So that's going to inspect the cells to make sure that they look good and ready to move on to the next station.
So what are you doing with iTrack that you couldn't do with another conveyance system?
It's a little bit more easily manipulated, so we could make this longer, shorter, modular, and what's really cool about it was they were able to drop the track segments into Emulate 3D, and then it actually produced the PLC code for us. So he put 4 different segments, maybe 6, and then he was able to put the movers on there, and then he just said, generate the code, and sent it over to me.
It was all generated for you?
Correct.
That's
yes.
very cool.
So that's something that you really couldn't do with a typical conveyance system.
Sure, yeah,
Yep.
Awesome.
And so after that, it goes into the laser ablation station. Typically, for our processes, you would use that laser ablation to treat the surface of the batteries, and then after that, it would go in and you would solder them together. So it has to be treated before that nice clean surface.
Gotcha. So you're cleaning off the surface and then they'll solder them together. So I guess right now on the show we're just simulating that process?
Yeah, otherwise, over time it would get discolored. After that, it comes around. In the back here, we've got a T-Bot gantry system here.
Okay, so who manufactures the T-Bot?
Macron does. So what's cool is it actually works kind of like an Etch-a-Sketch.
Okay.
Yeah, so you've got the 2 servo motors on the sides, and then you've got the belt that goes through.
And the servos aren't actually moving, nothing's moving other than the...
Correct.
Okay.
Yeah, so what's cool about that is you don't have as heavy of a load that's moving around. And then we have the 3rd servo here just for the rotate axis.
Gotcha.
And so then it's placed over here on the dial.
Okay.
And so this is actually controlled by another Convergix 5700. It's a servo. But then they have a cam that allows it to go into dwell. So when it's in dwell, then all the stations can advance and do their activity. So then it comes to this station here where all 4 of the cells are individually spinning.
Okay.
So that the barcode scanner can pick up on the barcodes that are printed on each of the cells. That helps them to be able to pick up data and track which one is which and what cells are good, bad, otherwise. And then from there, it comes around to the electrical test station where we're testing voltage and resistance. Of course, with the dummy cells here, it's just simulating that process, but that's something we would typically do in our systems.
And do you keep track of where the batteries are throughout the entire system?
Yes.
Okay.
Yep. So what's helpful is you can spit out just one individual cell if it doesn't test well here, or if the laser didn't look right, or the vision camera. At any point of the way, we can reject just one of those cells, and then you don't have to reject the whole module after putting it together.
Yeah.
So that is a good cost savings.